Hey everyone, in this video we are going to look at Rabin-Karp algorithm. So Rabin-Karp algorithm is also called as pattern matching algorithm, where we are given a string and let's say we have given the string Alice and Joe bake cookies, and we need to see whether the pattern Joe exists in this string or not. Okay, so if you see it does exist at this position, and we have to say that the pattern does exist. Okay, so for this particular algorithm we have to work with hash functions, and the algorithm, if solved in a general way, what we can do is just look for this particular pattern in the entire string, and if it exists, you get the solution and you return it. So that's not an efficient way of solving it. So we can use hash functions, which Rabin-Karp came up with. Okay, so let's look at a simple hash function first, so you understand how it works. So on the right side you can see I have made a table. So we'll create a hash function in which every letter that you see in this text is associated with a value. So from A to L I have 12, and then I have all the vowels here with some values. Okay, so in total we have 14 characters here, and each of them has a value. So what we are going to do right now is we are going to, with this table on the right, we are going to calculate a value for this particular pattern that we have, right? So if you see J, we have 10, so the value is going to be 10 plus O, and O is 13, and then we have E, which is 5, right? So this is nothing but 28. Okay, so 28 is the value. Now what we are going to do is we are going to go to the original input that we have of the long string and look at it. So to get the pattern here, what we have to do is we have to count the first three characters, which in this case are A, L, I, and the value of this based on this table is 1 plus L is 12 and I is 9, right? Which is nothing but 22. That is right. So for this, the first three characters, because the length of the pattern is 3, that's why we take a window of 3. Okay, it's 28, and we compare this 22 with 28. It doesn't match, right? So we know that this pattern doesn't even exist, so we don't have to check anything else, right? That's how we are going to find whether we can find the pattern in this original text or not, right? So we just move ahead. We can take the next three alphabets. Again we check, so the next three would be L, I, and C. So L is again 12, then I is 9, and then again we have C. C is 3, right, which is equal to some value, right? But if you think about this, if you think closely, you can see that we don't have to calculate the value again for L, I, and C. What we can actually do is we have already computed the value for L, A, L, and I, right? We just have to add the value C to this and remove A, right? So what we are going to do is for this particular value, we already have calculated 22. What we are going to do is we are going to remove the first value, which is 1, which means that we have removed A, right? And then we are just going to add the value, which is the next value, right, which is C, right, which is here, and the value of C is 3, correct? So what we get over here is like 21 plus 3, which is 24, right? So that's how we calculate the next three characters. We don't have to calculate for we add for each and every letter. So that's one way of thinking about it, and that's how we are going to use in the later algorithm as well when we take a different hash function. Okay, so that's the main idea about this hash function. If you think about the method that we just discussed, if you see we get some value for Joe, but if you see that if we do a simple hash function and we have a pattern which is something like this, the value for this is also going to be 28, right? And assuming we have some string which is like BC, A, BC, A, BC, A, and we need to find a pattern which is something like this, right? So if you see the number, the value is going to be the same for this, but it's also going to be the same for this, right? So we are computing, we are checking the character to character matching for every time we get a same hash value, right? So to avoid this, so this is the major drawback. So we can have the same hash values for multiple strings, right, which don't even match. So to avoid this, what we can do is we can actually look at the algorithm that is suggested, right, the hash function. So what we are going to do is we have this pattern again. We are going to write the values below. O was 13 and then E was 5, right? What we are going to do is we are going to multiply each and every number like this. When we do this, we get a value which is, let's calculate the value first. The value is going to be 1000 plus 130 plus 5, right, which is nothing but 1135, right? And what, so this is the value. But if we take the same string like this, so earlier this was 28 and this was also 28, right? Now let's calculate again. So it's going to be 13, it's going to be 5, it's going to be 10, and we do this again, right? So the value is going to be this plus this plus this, 1360. So if you see, now we have different values. So even if the string characters are same, since we are adding this to each and every string that we're calculating, we get a different hash value always. So this is one of the reasons this algorithm works in a very efficient way. So whenever we find strings where the pattern or the hash values are occurring again and again, the character to character matching that we need to do, if the hash value matches, reduces a lot. In this case also, there's a possibility that it can match, right? There is a possibility. But if you want to further analyze the algorithm, what we can do is come up with a different hash function. You can just do a mod with some prime number like 5 or 13 or some other prime number, and then you get a value again for this, and you get a value again for this, and then you get a unique value for each and every pattern that you're trying to find, right? So this is the method. So what we are going to do is, let me get this off again, sorry, right? Right, so we have this string, and if we use the same method, what we got was 1135 for Joe. So the same thing we are going to do for the first 3 letters that we have. So we have 1 into 10 raised to 2 plus L was 12 into 10 raised to 1 plus I was 9 into 10 raised to 0, which is nothing but 100 plus 120 plus 9, right? So it is 129, right, which doesn't match with this, right? 130 1135. Let me get that off, right? So that's fine again. So again, what we need to do is, for 1135, what we are going to do is, the interesting part over here is, before we were just subtracting the previous value for here, right? What we were doing was like just remove the 1 from here and then just add this part again to 9, right? This is what we were doing to get the next letter, that like I explained before. But that's not going to happen here, because we are doing multiplication a different way. So what we need to do is we need to remove this, right? So what we do is 129 minus 1 into 10 raised to 2, remove this, plus take the next letter. The next letter is C, right? That was L, I, and C, right? So the C would be 3 into 10 raised to 0, right? That's how we get the value for the next one, right? So L would be 12. Okay, so this won't be the same thing. So what we need to do is we also need to multiply by 10 here after we do the subtraction. Why? Because now the position of L was 10 raised to 1 here, but now this should be 10 raised to 2 because L is at the different location, right? So what we are going to do is, so let me write this again. So 129 was the previous value. We subtract the 10 raised to 2. We multiply by 10, right? Now what we get was, so now it becomes L into 10 raised to 2, then I into 10 raised to 1, right? And now we add the third one, which is 3 into 10 raised to 0. That's how we calculate the next LIC match pattern, right? And now we compare this value, whatever XX value we get, and we calculate that with Joe, right? This is how you do the matching. So when you keep on doing this, you come from here, you come from here, you keep on going, and you come at this location, and you come you get the value 1135. You check that 1135 matches with the pattern. Now we need to check whether the first letter of the pattern, so P of 0, matches the T of the wherever you are right now, right? Let's say I, right? And then you match. If it matches, yes, go ahead, plus, right? That's how you do the matching. This is what Rabin-Karp algorithm gives us, right? So this is the entire working, the flow of the algorithm. You can code this up and look how it works, look at some corner cases, and you can understand how efficient it is as compared to the normal brute force or the general approach that we have. That's it for this video. Thank you. Like, share, and subscribe if you like my content. I'm going to come up with different algorithm videos more. Hope this was helpful. Thank you.